So as I was saying, we need to, some have expanded to uh, the third bracket. It's still fine, but easier ways to use De Moivre's theorem, where we convert to, first of all, to polar form, and then we'll apply De Moivre's theorem to simplify. So, what was the root of negative, root of 4 squared plus, it's 5, right? So R is 5. I don't know what's the name. And we need to calculate our augment theta. So as I stated before, that just inspect into when you say tan theta, it's equals to, you'll have negative b over negative a, or negative 3 over negative 4. So I hope you see the ratio will be positive when you divide the negatives, but when you project on an Argand diagram, what is going to happen? We'll go 3 units to the left and 4 units down, right? So therefore we know that the complex number is projected where? In the um, on the third quadrant. So the angle that we'll be looking for from 0 to where we've projected, it gives us our angle theta. So we know that theta must be greater than 180. So we know that in the third quadrant it's at 180. So we're going to say plus. It's at 180 plus. Arctan the positive ratio, which is 3 over 4. Arctan 3 over 4. So therefore we got 1. It's 180 plus arctan 3 over 4. It's 1. Yeah, so it's 2, 2, 216. Okay. 8, 7 degrees. So yeah, now we have converted our complex number into polar form. So our modulus augment theta to 16.87 degrees. All in all, to the power of what? To the power of 3, isn't it? So all in all, to the power of 3. And we are very slow. The number disappears when I want. So we have that. And therefore, when you use what we call De Moivre's theorem, so we're going to raise 5 to the power of 3, which was supposed to be 125. The rule states that you must multiply the angle by 3. So you say 3 times 2, 16, which is 650, isn't it? 650, 0.61 degrees. So, but the question says that express the answer in rectangular form if given. So, which means we are going to change now from polar form to rectangular form and still express it in this way, in this expression of in this format, in polar form. Cos 650.61 plus j sine 650 space the comma 61 space. So this will help us to convert to rectangular form without using a calculator direct to convert. Your calculator can do that. So 125 times cos 650.61. Forgot to write it there. So it's 44, right? Minus 117 J. isn't it? And what did you get in your? Okay. So it's 125 times and 650 point, it was 61, right? 0.61. So we get 44 minus 117 J. So we have expressed it in rectangular form, the answer. Easy peasy. Now we need to, yeah, it's over done copying there. Just continue here. So we need to simplify the following. So this, when we inspect, though we get two solutions, when I mean looking into it, because normally when you have sets or roots, you are bound, maybe sometimes you get either positive or minus. So I'll advise that let's start in this way. First of all, we we can express what is inside the root as j to the power of 2, and you can factor our one exponent out. So it's j squared, right? J to the power of 4. So we know the exponential law state that we can say 2 times 2, which we're going to get 4. And the other one is an odd exponent. We have to split by adding exponent, or the rule of addition of exponents. So we have j to the power of 1 and j to the power of 2. When you multiply j to the power of 1 and j to the power of 2, you still get j to the power of 3. Then simplify it. You can deal with what is inside there. I hope you see we have j squared. We know it's equals to negative 1. Or some of you, if you want, you can get rid of the square, isn't it? That's another solution. But let's look into the one where we're getting a positive. So j squared, we said, is negative 1, isn't it? All in all to the power of 2. Therefore, we said j squared is negative 1. We have negative 1. J squared is negative 1. So we know that negative 1 to the power of 2 is negative 1 to the power of 2 is it's 1. And put a square root on 1, you're getting positive 1. And therefore, you'll have plus j. You have plus j. So that's another solution. So, but when you look into it, I just want to put the alternative in. Oh. So some, when it comes to the j to the power of 4, you can use the exponential laws. We know that changing the root into exponential format, it's 1 over 2. The other one we still express in the same way, j to the power of 1, j to the power of 2. So we know that according to the laws of exponents, we will say half times 4, which we are going to get what? J squared. In the meantime, j squared is minus 1 times that. It's going to be positive j. And the final answer will be equals to some of you saw that j squared, it is negative 1. So you have negative 1 plus j. So it's either you got plus 1 plus j or minus 1 plus j. Those are the solutions. So, 10 plus. Okay, let's quickly look into it was 1.3. 1.3.1, let me state that. But in 1.3, we're given Z1, which is equals to 4 augment 30 degrees. And Z2, space there. Z2, which was equals to 2 augment 60 degrees. So we need to divide Z1 by, I mean question 1.3.2. So let's look into 1.3.1. We need to multiply Z1 by Z2. So multiply Z1 by Z2. So we know that we are going to state, when we multiply, we're going to say 2 times 4 or 4 times 2, either vice versa. And we're going to say 30 plus 60 degrees. The law of the Moivre's theorem states that when we're multiplying, we only multiply the modulus and add the angles. Multiply the r's and add the angles. That's what we're supposed to do. So we know that 2 times 4 it's 8. Augment, we're going to have 90 degrees. So this one didn't specify that we need to leave our answer in rectangular form. But if you were supposed to leave it in rectangular form, you're going to say r into cosine 90, j sine 90. So read the instructions, so they didn't specify. So we can even leave it in that form. So 1.3.2, we're supposed to divide Z1 by Z2. So according to the division in polar form, so Z1 it is 4, or let me put it in this way. So we divide. So the other one is 2 augment 60 degrees. So when we're supposed to divide, we're supposed to divide the r's but subtract the angles. That is the rule. Divide the modulus, subtract the angles. Okay, I hope you see where you went wrong. Some of you. So it's 4 divided by 2, which is 2. Augment 30 minus 60 is negative 30 degrees. So you can leave it in that form. But if you have to convert into rectangular form, you know the trick. It was easy peasy, yeah? Straightforward. So in 1.4, we're given x cubed minus 2x squared plus 25x, which is equals to 0. So we are supposed to solve for x. We have to solve for x. So that's why in many cases, I hope we do the inspection here. I hope we see, first of all the terms are consistent. They consist of variable x. So which means at least you can try and find a common factor. That's the first thing, because these are algebraic functions. The methods of factorization, taking out the common factor, difference of 2 squares, plays a role here. So we take out the common factor of x, divide x cubed by x, we're left with x squared, divide by x, we're left with 2x, divide by x, we're left with 25, left all in all, it is equals to 0. So first of all, according to the rule, you can equate the factors equals to 0, So factor x is equals to 0, or x squared minus 2x plus 25. It is equals to 0. So what you're supposed to do, you try and figure out if you can factorize. You look for factors of 25. When you add or subtract, they will give you negative 2. You know factors of 25 is 5 and 5 as a whole number. So it's 5 and 5 and 1 and 25. So you see they are not giving you negative 2. So which means we move on to quadratic formulas. So using quadratic formula, we'll have negative 2 plus or minus into. For negative 2 to the power of 2 minus 4 into 1. C, it is 25. All divided by 2 into 1. It will be equals to. So we're going to get positive 2 plus or minus in the square root. What do we have? So it's minus 96 inside the root. So 2 squared is 4 minus 25, I think is 100. Yeah, it's negative 100. Then 4, you subtract from 4, you get 96. So I hope you see that we have to think of the rule of A by B, which when if let's say we have similar roots, we multiply the factors which are different. And so if let's say now we have to try and move from this part to splitting into roots. So we know that we need to make sure that we know it's undefined. I don't know which class I saw that they were writing not applicable. Maybe it's the other class. When I was marking, they wrote not applicable. And in class, we emphasize when it comes to this, that when you have a negative root, you can express the answer as a non-real number or in complex form. We know that first of all, we still stick with plus or minus. We have to split the root of negative 1, which is j. And root of 96 is 4. It was it 4 root 6? So it was 4 root 6, everything still divided by 2. So square root of positive 96 is 4 root 6. Square root of negative 1 is j. So that's what we did. We split the square root of negative 1 and square root of negative of 96. So now you leave your answer in rectangular form. So this is still in rational form. So we know that this denominator is shared by both numerators. So 2 is divided by 2, which is 1, plus or minus. 4 is divided by 2. We're going to have 2 root 6. Let me write it in rectangular form as j. So we just divided 4 by 2. We got 2. We divided 2 by 2. We got 1. She said home shell. You're thinking about time which has elapsed. So you can do this one in 2 ways. But I will always show you the shortest ones. But in math, please know how to simplify in 3 dimensions. So first of all, we inspect, we have a left and right hand side. There's variable x and y now. Now this is complex equations where we have to solve for complex equations. Variable x and y. We said the first thing, variable x and y, they must be on one side. It's either left or right hand side. At least the given equation, variable y and x are on the left hand side. And on the right hand side, we just have the complex number. But we have to simplify it first before we equate the real part of the left hand side and the real part of the right hand side. So we see we need to simplify because we still have a division of complex numbers. So first of all, we know we need to say j to the power of 1 and j to the power of 8, isn't it? J to the power of 8, we know can say 2 times 4. J to the power of 8 is 2 times 4. Then all divided by 1 minus j. Therefore, you'll have x minus j minus jy equals 2. So not to waste time, we know that j squared is negative 1. Negative 1 to the power of 4 is positive j, isn't it? It's a positive 1 to say it multiplies j, then we have j. Therefore, 1 minus j. Then we have x minus jy equals 2. So we're inspecting, we're having division of complex numbers. We can utilize the method of applying 1 there using a conjugate of the denominator. So we are going to state that when we multiply by 1, we're going to use the conjugate of the denominator, which is 1 plus j, all divided by 1 plus j. But this still divides itself, it still goes to 1. So in the meantime, now we can multiply numerator by numerator, denominator by denominator. So if we multiply, we're going to have 1 times 7, 7 times j. 7j minus j times 1 is negative j. Okay, let me write it as j squared, negative j squared. I wanted to skip the step. So please recall when I said always when you multiply using a conjugate, you'll have difference of 2 squares in the denominator. So just multiply 1 times 1 and then 1 and negative j times negative j. We'll have negative j squared. The middle term is always eliminated because we have negative j plus j. I hope it still makes sense. So jy equals to, let's add like terms. All right, so negative j squared is positive 1. I hope you see that. Because j squared is negative 1, multiplies the negative, we have positive 1. It's going to add with 7, we will have 8. So 7j minus j will have 6, positive 6j, all divided by. So j squared is negative 1, multiplies the negative with positive 1, plus 1, which is 2. So we still have to express it in a proper rectangular form. We need to have real part and imaginary part. So we see 8 divided by 2, which is 4, plus 6 divided by 2, which is 3j, which is 3j. So now according to the rule, we can equate the real part of the right hand side and the real part of the left hand side. And we'll have to do the same thing with the real part, the imaginary part to say. We take the coefficient of j. Take the coefficient of j. So we're going to say that x, the real part of the left hand side, is equals to the real part of the right hand side. And the coefficient negative y, let me stick to negative y, is equals to the coefficient of j on the right hand side, which is 3. So therefore, at least x we have it is equals to 4, but y we need to make sure we simplify fully because it's equals to negative 3. So we have taken the common coefficients of j's and solved both sides. Okay, hope that was clear. Though some of you might have applied it in this way, we still have the same answer. I think let me just put it where I'm chasing time. Let me put that alternative. But I think this was the simplest way. Just deal with the right hand side. You're done. The one of cross multiplying, it takes forever. You end up leaving out some terms. But math, it's math. Please make sure. Oh, we have 7 minus j to the power of 9 minus j. So alternatively, you can solve it in this way. If you want to get rid of this denominator, because it's an equation, you can multiply on both sides by this denominator on both sides. If we multiply by 1 minus j on this side, I hope you see it divides, we'll be left with 7 minus j, for j to the power of 2, all in all to the power of 4. When you multiply it. But when you multiply on the other side, I think let me express it here. If we multiply by 1 minus j, we'll have that. So according to the laws of algebraic fractions in equations, when you multiply the left and the right hand side. So that's why you think the 8 disappeared. We didn't cross multiply. It's because we multiplied by 1 minus j, it was divided, and we multiply on the left hand side. So let's multiply x times 1. We have x times j, we have xj. In fact, it's a minus, right? It's a minus xj. The minus jy times 1 is minus yj. n minus times minus is positive. Therefore, yj squared. J times this j squared. So then on the right hand side is the same way we simplified initially of having 7. Therefore, because this is positive 1, you still have minus j. So still have positive 1 multiplied negative j. Then on the right hand side, the rule says that you must make sure that you group the real parts together and the imaginary part together. And make sure variable x and y are on one side. So everything's on the right and left hand side consisting of x and y. So we have to group the real parts. Which one doesn't consist of j? So I hope you see if we simplify y j squared, because j squared is minus 1 times y, it will be negative y. So we group it with x. These are the real parts. So x minus y, they're the real parts. The other one, we need to group 1 plus. What I'm going to do, we have minus x and minus yj. So I'm going to have minus x. I'm going to factor out j. Minus x minus y. Factor out j. I'm writing it in a rectangular form. I must have a plus b times j. So these two, we group them together, the common factor, took out j. Just left the negative. If you wanted the negative, you could factor out the negative. Then it's equals to 7 minus j. Now we need to equate the real part of the left-hand side with the real part of the right-hand side. The real part, it is x minus y equals the real part of the right-hand side, which is 7. Which is going to give us equation 1. We have equation 1. So some of you were trying to multiply. This is how you are supposed to solve it. Yes. Now we need to equate negative x minus y equals to the coefficient of j on the right hand side, which is negative 1. So I hope you see the common factor, the coefficient of j, negative x minus y. It's equals the coefficient of the imaginary part on the right hand side. So that is equation 2. So you can choose which one you need to manipulate and make x subject of the formula y. All right, so let's simplify this one. X is equals to 7 plus what? Plus y. So I've made that, let me call it equation 3 from that one. So, but I want to substitute x, or let me substitute, let's say 3 into what? Into 2, because I made this equation 3. So in this equation, we're going to substitute the x value, where we substitute 7 plus y, therefore minus y equals to negative 1. So I'm not going to waste time. You'll see terms going to the other side. So I hope you see we're going to have negative y, isn't it? And therefore, we get what? Negative 2y with that one. Then when we multiply this, we're going to get negative 7. And then take negative 7 to the other side is going to be positive 7 and minus y, which is going to be 6. Therefore, y it is equals to, when we divide by negative 2, it's negative 3. I hope you still get the same answer using the cross multiplication. Now, from equation 3, we substitute and get x. We need to get the x value. So I'm substituting into equation 3. Therefore, the answer will be x will be equals to 4. So x is equals to 4. I hope it's clear. So we get the same answer. Those who took this longer route, routes. So that's how we're supposed to go. Mr. Mtomase. Oh, there's a meeting. All right. Forgot. Don't you want me to put the last one? I don't have another time. Okay, 1.6 ish. I want to go the determinant 2, 3, 6, 4, 1. Sorry for rushing. 1, 6, 5, 2. It says we must determine the minor of 5, right? Minor of 5. 5, where's 5? 5 is in row what? Row 2, column 3. So we got there. We're in 5, isn't it? 5 is there. So which means we must eliminate horizontal and vertical from 5. Horizontal and vertical. So the element that are left, we have our minor of 5. So minor of 5 is 2, 4, 6, 1. That is the minor of 5. I'm surprised how you didn't get that while I even do the crossing in color for you not to forget. So we have eliminated there, we have our minor, the element. So we multiply, evaluate is 2 times 1, which is 2. Therefore, minus 6 times 4, which is 24. Therefore, our minor is negative minus 22. Easy peasy. Just like that. And the cofactor is A, therefore we said it's in row 2, column 3. Therefore equals to negative 1 to the power of the row is 2 plus column 3. So which we have to the power of 5. Therefore minor, if you wanted to follow up, you're going to write minus 22. We know you got it from top. Or you say 2, 4, 6, 1. That is the minor of 5. Therefore, we're going to get negative 1 to the power of 5 is negative 1, isn't it? Therefore, evaluation of this is minus 22. But to show it's 2 times 1 is 2, minus 6 times 4, which is 24. Answer is equals to, we had negative 22 times the negative, positive 22. That is the cofactor of 5. Cofactor of 5. Cofactor of 5. Very easy peasy. So I'm not going to complete this one, but we're given these equations 1 over x. We need to solve for z. Hey, the one who was using this question paper. So 2 over y plus 1 over z is equals to 1 over 2. The other equation is 4 over x plus 2 y minus 3 over z equals to 2 over 3. Other one is 3 over x minus 4 over y plus 4 over z equals to 1 over 3. So quickly, I just want to show you how you could deduce the determinants. Some of you deduce them accordingly, but I want you to pay attention to what is happening. We're having variables in a fraction form. So which means, for an example, I'll just extract y, for an example, y there. So which means we have 2 into 1 over y. So we're not having the coefficient of y, we're having a coefficient of 1 over y. I'm just give an example with y up there. So when you deduce, you're going to take the coefficients of your inverse functions. It's an inverse one. Remember when you're solving the resistance in parallel, the 1 over r. So you need to apply that at the end, the inverse. So when you deduce, you're going to deduce delta. Delta, it's an inverse one. So it's delta there, it's an inverse one. Therefore, You can take the coefficient of your 1 over x, which is 1. Coefficient of 1 over x is 4. The other one is 3. The other one is 2. We have 2, negative 4. We have 1, negative 3, 4. That is our delta. So we have taken the coefficients of 1 over x, coefficient of 1 over y, coefficients of 1 over z. It is our delta, the inverse delta. So when you deduce, you know that you evaluate from using row method, it's easier. So we know output is going to be positive times 1 minor of 1. So you will be eliminating from 1 there, doing that. And have 2 minus 4, negative 3, 4. The other one output from cofactor there, it will be negative 1. Therefore, multiply by 2, the minor of 2 now. You're into there, eliminate horizontal and vertical. Or maybe some of you chose to go via the column evaluation. Still get the answer. So a 4, 3, negative 3, 4. And the other one, let me try and put it here, is going to be plus the output. So we're going to the last column, first row. Therefore, the minor. So the minor we're in 1 now, vertically and horizontally. So the minor will be 4, 2, 3, minus 4. So we can evaluate now. We can evaluate. So we're going to have in 2 times 4, which is 8, minus 4 times negative 3, which is 12, isn't it? Therefore, minus 2 into 4 times 4, 16, minus 3 times negative 3. We have negative 9, isn't it? Therefore, plus into 2 times negative 4, it's negative, did I say 2? It's 4 times 4, which is negative 8. Therefore, minus into 3 times 2, which is 6. You can get the answer there. Which one? Yeah, 16. Thank you. So I have 16 there. But the answer that we're getting, you got what? Negative 76, not to waste time. You got negative 76. I saw your calculation. So therefore, that is delta, isn't it? So therefore, do the inverse. The inverse delta is going to be what? Negative 1 over 76. Applying the inverse of your delta there. Or you can get rid of the negative, you multiply it on the other side. Goes to be 1 over negative 76. So you're going to do the same thing when you're solving for z. It is the delta of z, which is going to be equals to. We are going to replace now the column which consists of z. There's the last column. Which elements are you going to use? 2, negative 4. So I'm going to use 1 over 2 and so it was 2 over 3, no? And 1 over 3. The evaluation, it is still the same. We can continue with it from there.